Hello everyone and welcome to my presentation about the facility design. Today we are going to talk about the very important topic in operations research and supply chain management. When organization wants to build a new factory, a new warehouse or hospital or something similar, they cannot just pick a random place. They have to do some mathematic practice and they have to do some research. Then they need to make the strategic decision. So, using the strategic decision methods and advanced optimization and allocation models, in this presentation we will look at the different mathematical approaches. Some of these models help us to minimize cost, some of maximize service coverage, and others improve quality. This is depends on the main idea. Our main goal is to see the how we can use data and math to solve complex location problems in real life. Let's start with our first model type, P-center problems. First, we need to check the P-center problems. What's the P-center problem and what's the main goal of the P-center model? The P-center model is so simple. It wants to minimize the maximum distance between any demand point and nearest facility. We also call these as minimax problems. Why? Because they look at the worst case scenario. Instead of making the average distance good for anyone, it ensures that no single customer is too far away from the service. This is very important for equity, meaning fairness. For example, think about emergency services like fire stations or ambulances or police stations. You don't care about the average time. You want to make sure the furthest house can still get help quickly. This is the main idea. There are different type of P-center formulations. The first one is continuous P-center. In this version, you can put a facility anywhere you want in the network space. There are no limitations. This gives you the perfect mathematical position, but it's very hard to calculate because there are infinite possibilities. The second type is the vertex P-center. This approach is more practical because it resists facility placements to existing network nodes only, like specific cities or intersections. It simplifies the math and matches real-world instructional limitations. Finally, we have the demand-weighted variant. Here we incorporate customer demand volumes into our distance calculations. Locations with higher demand get priority, which helps balance fairness with operational efficiency. Now we are going to look about absolute one center and second two center algorithms. The first one is absolute one center. This is used when we want to find the optimal location for just a single facility on an unweighted tree network. The algorithm has three simple steps, as you can see in the slide. Select any node and identify the farthest node. From first node, find the farthest node in the network. The absolute one center lies at the midpoint between these 2 points distance. You know, if you must place the facility on existing node rather than a midpoint, you use vertex center identification. You simplify, find the network node closest to the calculated midpoint. This gives you the best discrete location, actually. Now we are going to talk about the absolute two center problem. This is for dual placement, not just for one facility. In this method, we are going to talk about more than one facility. To solve this, we use three division strategy. First, we find the absolute one center using the same steps with absolute one center. Then we remove the arc, the road or link that contains this center point. This splits the original tree network into two separate subtrees. This division creates two independent regions actually. In the final, we apply the one center algorithm to each subtree independently. Uh, Actually, we are going to apply the absolute one center methods for these independent regions. Then this gives us two centers that minimize the maximum distance across the both portions, ensuring balanced coverage. Now we are going to talk about location allocation problems. Unlike p-center models that look at the worst case distance, location allocation models simultaneously determine the optimal facility locations and assign customer to them to minimize total system cost. First, we need to check about the unsubstantiated location allocation model. First, this model means the facility have no capacity limits. They can serve as many customers as needed. This model balances classical trade-off. If you open favor facilities, your fixed costs are low, but your transportation costs up uh, go up increase because customers are far away. If you open more facilities, your transportation cost going to be down, but your fixed cost going to be up. Uh, this model analyzes four main components to find perfect balance. Uh, Fixed facility cost, transportation cost, demand satisfaction, and optimal selection. Uh, in this slide, we are going to talk about comprehensive models and extensions. In real life, supply chains are more complicated than the basic framework. That's why we use comprehensive location allocation model. This model handles multiple products, multiple manufacturing plants, intermediate warehouse, and customers. It considers a multi-tier network where capacity limitations and cost at every level must be optimized at the same time. To make these mathematic models work as decision support tools for real business, we can add model extensions. These extensions allow use to include corporate policies, budgets, contracts. Let me give you an example. Warehouse quantity limits, present precedence relationships, service constraints, assignment rules. To summarize, choosing the right model depends on your business goal. If you are designing emergency networks, use the P-central model to minimize maximum distance. If you have three-shaped networks, use one or two central algorithms. And if you want to balance fixed and variable expenses for a regular supply chain, use location allocation models. Thank you for listening my presentation. In next videos, we are going to continue the explanation uh, these models. I'm now happy to open the floor for any questions for discussions you might have. Thank you for listening.